Discrete random variables. Consider rolling a standard, fair cubical die. We can define a discrete random variable as x, the number showing on the uppermost face when the die is rolled. So our standard fair cubical die, as it says here, is numbered 1 to 6. When you roll a die, if a 5 is showing uppermost, then that would be the value of x. Now, we called this a discrete random variable. So why? It is discrete as the domain is discrete. X can only take the values 1, 2, 3, 4, 5, or 6. It can't take the number a half. It can't take the number pi. It is a variable as we will get different results when we roll the die a number of times in all likelihood. It's very unlikely that we're going to get all of the same result, i.e. that all of them might be 6s. It is random as we do not know the outcome before we roll the die. Hence we have the term discrete random variable. Note that we can state the probability of each possible outcome, but not the outcome itself. In this case, we can simply state the probability function, p of x, that's the probability that x, our random variable, takes a particular value in its domain, small x. So the probability of x in this case is 1/6 for each of the possible numbers in the domain. In other words, something you've known for years, if it's a standard fair cubical die, the probability of getting a 2 is 1 out of 6. Note, there are other ways of stating the domain, such as x is a natural number, x is between 1 and 6, and that's another way of stating this. Sometimes this domain might be stated without the x belongs to the natural numbers, but I prefer it to be there, so I would normally write that. We may also state the probability of x, remember again that's shorthand for the probability that the random variable x takes a value in its domain x, is 1/6 if x is in this domain and 0 otherwise.